Hi everyone, in this video I'm going to build the envelope detector circuit which is in section 2 of your lab handout. Now this circuit consists of a voltage follower at the input which acts as a buffer, and then the envelope detection module which consists of a 1N914 PN junction diode and then a 1 mega ohm resistor in parallel with a 47 nanofarad capacitor. The input voltage will go directly to the non-inverting terminal of the op amp, and the output voltage will be taken as the voltage across the capacitor. So the very first thing that I'm going to do is I'm going to set my ground. So I'm going to take a black cable from the 82 and connect it to this rail so that this entire rail has a ground voltage of 0 volts. Now I'm going to place my op amp into the circuit. Now the purpose of this op amp is to act as a voltage follower that will essentially transmit the input voltage to the output terminal, which can then go to the envelope detector. So I'm going to connect a cable from the inverting terminal of the op amp to the output terminal. The inverting terminal is second to the top, and then the output terminal is third from the top or second from the bottom. Okay? Now once I have this, I can supply my input voltage from the waveform generator to the non-inverting terminal of the op amp. And so the wave gen input comes from the cable labeled W1, which is solid yellow. And so I'm going to connect this directly to the positive terminal, the non-inverting terminal of the op amp. Now we have our voltage follower configuration. Now what I'm going to do is I'm going to add the envelope detection module, which consists of the 1N914 PN junction diode and then the RC parallel configuration. So first I'm going to connect the 1N914 PN junction diode. I'm going to connect the positive terminal, that is the terminal without the black line, to the output of the op amp. And then I'm going to connect the negative terminal, that is the terminal with the black line, to this point in the circuit. Now once we have the PN junction diode connected, we can add our resistor and capacitor parallel configuration. So for this lab we're going to use a 47 nanofarad capacitor, which is labeled as 473 in your kit. So take out the 473 capacitor. Now since this 473 capacitor is not an electrolytic capacitor, it's a ceramic capacitor, it does not have a specific polarity, which means that we can connect it in any polarity to our circuit. So connect one terminal of the capacitor to the negative terminal of the PN junction diode, and then connect the other terminal of the capacitor to a different node in the circuit. Once we have the capacitor in place, we can add the parallel resistor. Now since we're using a 1 mega ohm resistor, 1 mega ohm corresponds to the color combination of brown, black, green. So take the brown, black, green resistor from your kit and then place it directly in parallel with the 47 nanofarad capacitor. Alright, now the last thing we have to do in terms of building the circuit is to connect the negative terminal of the capacitor and resistor to our ground. So what I'm going to do is I'm going to take this wire here and I'm going to connect it from the negative terminal of the capacitor directly to ground. Alright, so we have our voltage follower. We're supplying the input voltage to the non-inverting terminal of the op amp, and then we have our envelope detection module, which consists of the PN junction diode and then the resistor in parallel with the capacitor. Now the last thing we can do before setting up our measurements is that we actually have to power the op amp being used in our voltage follower. So to do that, I'm going to take the red V plus power supply cable corresponding to the power supply, and I'm going to connect that to the second to top terminal of the op amp on the right. That corresponds to the V plus power supply. Now what I'm going to do is I'm going to connect the V minus power supply, or the negative power supply, to this rail here, just to make things a little neater. So now this entire rail on the left has a voltage of V minus, which we're going to set to minus 5 volts. And now I'm going to connect this rail to the very bottom terminal of the op amp on the left side. That corresponds to the V minus supply. Alright, so we have our op amp based voltage follower set up. We're powering the op amp with V plus and V minus. And then we have our envelope detector, which the negative terminal of the capacitor is connected to ground. So this is it in terms of the actual circuit. Now all we have left is to set up the channel 1 and channel 2 measurements, where channel 1 is going to be measuring the voltage at the input, V in of t, and then channel 2 is going to be measuring the output voltage across the capacitor. Alright, so to set up channel 1, I'm going to take the solid orange cable labeled 1 plus, scope channel 1 positive, and I'm going to connect that directly to the input node here. Also, I'm going to take the scope channel 1 negative cable, which is orange with a white line through it, and I'm going to connect that directly to ground. Next, I'm going to set up my channel 2 measurement. So I'm going to take the solid blue cable labeled 2 plus, so scope channel 2 positive, and I'm going to connect that to the positive terminal of our capacitor. And then I'm going to connect the scope channel 2 negative cable, which is blue with a white line through it, and I'm going to connect that to the negative terminal of the capacitor. Alright, so we finished setting up our envelope detector circuit. And in the next video, I'm going to perform the 3 measurements that you're asked to carry out in section 2 of your lab handout.